Hello, today we're going to look at a calculation involving standard form or scientific notation. The two terms are interchangeable. Now before we do that, let's just do a little bit of revision on standard form. So I've got two numbers here in, I suppose, what we might call normal form and also in standard form. So standard form, the first number has to be between 1 and 10 and the second number is a power of 10. So a little bit of revision of how we might do that. So we look at our normal number and we put the decimal point so it's between 1 and 10. So 4.6, that's how we get our 4.6. Then we count back to the original decimal point, which is there, and that's going to give us our powers of 10. So let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 jumps. That's why the power of 10 is 9 there. Same sort of process for this number. This is a very, very small number. Sorry, what I should have mentioned earlier was this is the approximate age of the Earth in years, and this very small number is the approximate age of a carbon atom in grams. So same process, put the number in to make, put the decimal point in to make the number between 1 and 10, so 2.03. And then to get the powers of 10, we count back to the original decimal point, which is here. So 1, 2, 3, etc., etc., etc. And if I counted all the way back, I would get 23 jumps. And just a reminder that standard form or scientific notation is used usually as a more efficient way of writing very large numbers or extremely small numbers. Now for a calculation. Excuse my writing here, but it's what is the weight of 4,000 carbon atoms if one weighs 2.03 multiplied by 10 to the power of negative 23. So we want 4,000 lots of that carbon atom. So 4,000 times 2.03 multiplied by 10 to the power of negative 23. So the way I do this, pretty straightforward with a calculator, but we're going to assume you don't have a calculator. The way I do this is I'd convert this number into standard form. You don't have to do it this way, but you can if you want. So I'm going to put the decimal point in there. So the number is between 1 and 10, so that's 4.0. We'll just write 4. Count back to the original decimal point, 1, 2, 3. Therefore it's 10 to the power of 3, because of the 3 jumps. And then don't forget the rest of the calculation. Right, let's multiply what we'll probably call the normal numbers together. 4 multiplied by 2.03, that's 8.12. Now the powers of 10. Let's apply our index laws. So we're multiplying together, therefore we're going to add the indices. So we're going to add the 3 to the negative 23. So if you did negative 23 add 3, that would give you negative 20. So 4,000 carbon atoms weigh 8.12 multiplied by 10 to the power of negative 20. And just before I finish, just one thing to be careful of. You've got to check this number is between 1 and 10. If it's not, you will have to do some more manipulating from there. But in our case, it's between 1 and 10, so there's no need to worry about it. Goodbye, and thanks for watching.